Welcome to Brain Vision.
So for this problem, we have two cannonballs. One is fired straight up and the other is fired at an angle of 37 degrees. And they're both fired at 1,000 meters per second. So first I want to find the vertical component of the ball's velocity. So the one that's shot at an angle will be harder to get. It's going to be the velocity times the sine of the angle, which is this angle right here. So that's going to be 1,000 meters per second times the sine of 37 degrees, which is 601.8 meters per second. So that's that velocity. And then the vertical component of the other velocity is 1,000 because all of it's directed in the y direction. So now we want to figure out how high it goes, and I can use conservation of energy. So change in kinetic energy is going to be the opposite of the change in potential, which is 1/2 mv squared, and I'm going to say vf squared minus v initial squared. That's the change in velocity. And then the change in height is going to be y final minus y initial. The velocity initial is, well, what we got here is either 601 or 1,000. And then the velocity final is 0. So this comes out to minus 1/2 m v initial squared equals minus mg. And then the final height is h. And then the initial height is 0. So this is just mgh. And then the minus and the m cancel away. And I'll solve for h, so we get h equals v initial squared over 2g. So h1, which I'll call the height of the first ball, so this height is going to be 601.8 squared over 2 times 9.8, which is 1.85 times 10 to the 4th meters. And the height of the other ball is going to be 1,000 squared over 2 times 9.8. And that's 5.1 times 10 to the 4th meters. Now, the total energy once each ball reaches its top height, well, actually any time in the ball's flight path is going to be exactly the same. And they're going to be the same as each other because they're both fired at the same initial speed, so they have the same initial kinetic energy. So whatever energy they have at the end, the final energy, for one of them it's just going to be only potential because it comes to a complete stop, and then the other one, it has some horizontal component of velocity, and so, but it also has less potential. So either way, they both have the same final energy, which is the same as the initial energy. I'll say EI, I guess. And the initial energy for either one is just the kinetic energy, because they have no potential. So that's 1/2 m v initial squared. And now we're dealing with not just the y component of the velocity, but the entire velocity. So for either one, we have 1/2 times, well, the mass is 20 kilograms, and the velocity is 1,000 meters per second. This comes out to 10 to the 7th joules.